The goal of this video is to summarize top energy saving recommendations given to food processors in recent years. To clarify, a recommendation refers to an action that should be taken by the facility in question. Some examples include purchasing new equipment, updating procedures, or otherwise changing normal business operations. Specific recommendations chosen for this video have been grouped into 7 categories based on their similarities. The categories are boilers, electricity, compressed air, heat recovery, lighting, motors and controllers, and insulation. Each category holds a significant opportunity to reduce utility costs for those willing to take advantage of it. The content in this video is an overview. If you would like to learn more about one recommendation in particular, refer to the supplementary videos on each category. The title for each supplementary video will be listed in the conclusion of this video. The United States Department of Energy Industrial Assessment Center program, or IAC, is over 4 decades old and delivers service through more than 30 different university-based centers. The program is designed to help manufacturers and industrial facilities save energy, improve productivity, and reduce waste. IAC's centers have conducted more than 19,000 facility assessments, which have resulted in 145,000 individual recommendations and an average annual savings of $137,000 per facility. To prepare this video, specific recommendations for the food processing industry have been identified on the IAC's internal database and evaluated. The following information has been selected due to their high recommendation and implementation rates, which showcase a strong economic incentive, reduction in risk, and a collective agreement that the change is beneficial. Steam is an essential input for many types of food production, whether it is being used to manipulate the product, provide heat, or just to operate equipment. Optimizing your boiler system and steam delivery system can result in significant water, natural gas, and ultimately dollar savings. The 3 most commonly implemented recommendations are to install an economizer, minimize steam leakage, and confirm that the air-fuel ratio is correct. Installing a heat economizer to capture waste energy from your boiler reduces the cost to create steam and can improve the longevity of your boiler. Economizers are a type of heat exchanger used to recover waste heat otherwise lost to the atmosphere. According to the IAC database, economizers have saved manufacturers more than $31,000 annually and an average payback period for the equipment purchase of 1.9 years. Confirming that the boiler flue gas has the proper air-to-fuel ratio also saves energy. A poor ratio indicates that incomplete combustion is occurring and excess natural gas is being used. Testing can be done periodically by many boiler service companies, or it is possible to work with organizations such as the IAC to gather a spot check. This ratio will vary depending on the specifications of your boiler, but it should be somewhere in the range of 10 to 1. If the ratio for your boiler greatly differs from this, there may be something wrong. Minimizing steam leakage is another way to reduce resource consumption and save money. A maintenance system should be in place to identify where steam is leaking and also fix the issue. Not attending to leaks in the steam lines and steam traps in a timely manner is like throwing money out the window. Not only is the energy used to create steam wasted, additionally, steam must also be created to replace what has been lost. During a recent facility assessment, it was estimated that as much as $100,000 was wasted annually due to steam escaping from pipes and faulty steam traps. Electricity is typically the most expensive utility for food processing facilities, and therefore holds the greatest potential for savings. The IAC has a number of common recommendations to realize electricity savings. The first is to optimize plant power factor. Power factor is a ratio that describes the working power requirements and apparent power usage of your facility. It is common for local utilities to charge very high rates when plant power factor is below a certain benchmark. Placing capacitors in the engine room or near large pieces of equipment is one way to reduce energy loss and the subsequent kVAR charges. The IAC database has seen an average annual savings of more than $14,000 by improving power factor. Payback periods range from 2 to 10 years depending on the situation. A second recommendation is to turn off equipment when it is not in use. Equipment should always be powered down when it is not in use. Unnecessarily leaving equipment on will drive up usage and even demand charges if the equipment is left on during peak hours. There is no initial cost to implementing this practice, and facilities have seen an average electric savings of $13,000 annually. A third common recommendation is to implement some sort of demand management system. These systems come in many forms, but the central idea is to divert electricity usage away from peak periods by distributing consumption more evenly throughout the day. For those unfamiliar, electric demand is a measurement of the rate at which electricity is consumed. Utilities often average demand over 30-minute periods and charge you based on the highest average during one billing period. Well-operating processors may have 30 to 50% of their electric costs dedicated to demand. Those with more than half dedicated to demand charges will want to look into demand management systems. Annual savings and the cost to implement this recommendation vary greatly depending on what kind of system you select. Many food processing facilities utilize compressed air for processing purposes and equipment operation. The financial burden related to compressed air can be reduced in several ways. One way to reduce the overall usage is to eliminate compressed air lines in the areas that no longer need it. The compressed air supply system for your facility should not run to abandoned equipment or be utilized in an inappropriate manner. On average, food processors have saved more than $5,000 each year by simply closing old lines and halting inappropriate uses for compressed air. If the air intake for compressors is in a hot enclosed utility room, installing new intakes which draw cooler air can be beneficial. Cool air is more dense than hot air, so essentially you can think of air already being partially compressed. Therefore, when a compressor is fed with cool air, it does not need to work as hard to compress the same volume of air. According to the IEC database, cool air intakes save more than $3,800 on average and pay for themselves in 1.4 years. Eliminating leaks in compressed air lines and valves is also useful. Disregarding leaks in the compressed air system leads to an accumulation of wasted energy and money. According to the Department of Energy, compressed air leaks can often account for 20 to 30% of a normal compressor's operation. This means with no leak repair program, you are paying 20 to 30% more than necessary. The IAC has observed an average annual savings of $8,000 and a payback period of just about 5 months for this recommendation. Waste heat is free, so why not use it to reduce your normal operation costs? One recommendation made by the IAC is to recover waste heat from equipment. Waste heat can either help preheat media for the same piece of equipment or be recovered and utilized elsewhere. In some cases, this practice can eliminate the heating equipment for other processes altogether. On average, this recommendation has saved food processors more than $30,000 annually. Another specific recommendation is to use waste heat from hot flue gases to preheat gases or liquids. This is commonly done on smokestacks and boiler flues. Installing a heat exchanger in the proper location will reduce the cost to heat and improve equipment efficiency. This action has saved an average of more than $30,000 for food processors annually. It is common for food processing facilities to run multiple shifts in one day. With this model, lights remain on longer and sometimes even 24/7 to avoid startup. With this increased runtime, a number of different lighting upgrades become economical. The first upgrade you should consider is installing higher efficiency lamps like LEDs. LEDs have the potential to save money in several different ways. For one, maintenance costs will be reduced due to the increased longevity. Electric costs will also be reduced because LED lamps typically require 1/3 of the power traditional fluorescent lamps require to produce the same lumen output. Additionally, many local utilities provide incentives and rebates to businesses looking to reduce their electric usage by installing LED lighting. There is a wide range of choices for LED lamps and fixtures, and the price for each differs greatly, but it is typically cheaper to retrofit existing fixtures instead of completely replacing them. Another lighting upgrade is to install occupancy sensors. Commonly referred to as motion sensors, this controller can sense when personnel are present in a given area and manage the lights accordingly. Occupancy sensors ensure the lights are powered on only when they are needed and also increase fixture longevity. The initial investment is relatively cheap. Sensors can be found for as little as $20 online. This recommendation has an average savings of $3,000 annually with a typical payback period of just over 1 year. Additionally, it is recommended to reduce the illumination to the minimum necessary level. There is such a thing as too much light. Reducing the number of lights or bulb wattage within reason will allow work to continue safely while also saving on electric costs. According to the IEC, reducing the illumination level has saved facilities more than $4,500 annually. The cost to operate motors and other equipment can often be reduced by adding some type of controller. With a controller in place, the operation can be optimized and nearly eliminate excess resource usage. Using an adjustable speed drive on existing systems is the most common way to do this. Variable frequency drives, or VFDs, are a subset of ASDs. These controllers save energy by reducing the operation speed of motors. Processes that require varying loads or operate on intervals can benefit from a VFD retrofit. In the right applications, VFDs can save more than $20,000 annually. It is common for utility providers to offer rebate programs on VFDs. With these rebates, an average payback period is brought down to just 1.8 years for this equipment. Similar to VFDs, it is recommended to utilize other control systems to operate equipment only when it is needed. This differs from the previous recommendation because there is no way to adjust the speed of operation here. This is simply an on-off controller. These systems come in many different forms. A simple example would be adding sensors to some process and then adjusting it based on the collected data. A more complex example would be adding a completely automated wastewater pretreatment system where operators only need to fill coagulant or complete other supporting tasks. Thermal energy transfer between pipes or equipment and ambient temperatures is more significant than most people realize. Leaving portions of these things uninsulated results in the loss of energy as well as a decrease in efficiency. One recommendation from the IAC is to reduce thermal energy loss by insulating bare equipment. Any surfaces such as piping, tubing, or equipment panels that are hot to the touch should be insulated. This increases efficiency and additionally protects workers from accidental injury. An average annual savings of $7,000 and an average payback of just over 1 year has been reported for facilities that implement this recommendation. It is also recommended to install and repair insulation on steam lines. As previously noted, steam is expensive. Adding insulation will help minimize the loss of energy and also reduce blowdown. According to the Department of Energy, properly installed insulation can reduce energy losses by 90% and additionally improve steam pressure throughout the plant. This completes our list of top energy saving recommendations made by the IAC for food processors. If you are interested in learning more about one of the topics mentioned in this video, check out the resources listed here. We go into much greater detail about the 7 categories I just discussed and the recommendations housed in each one. Additionally, we have created a separate series that covers how to properly determine the relative cost of water for different areas in a food processing facility. This series begins with an overview of the relative cost of water. It then moves into water mapping, which is an essential step to understand how water is used in your facility. Next, how to properly add various costs to different water streams is covered. Additives such as chemicals, heating, and wastewater charges are included in this section. Finally, there is a brief summary of equipment and procedures commonly implemented to reduce water consumption. Check out the resources listed here to get more information on this series. I hope this video has helped you think about what improvements can be made to your facility to reduce resource consumption and also see the benefits translated to annual savings. Thanks for watching.